We continue learning workbook page 186 with this problem that you might see in Alex. The number of bacteria in a certain population is predicted to increase according to a continuous exponential growth model at a relative rate of 13% per hour. Suppose that a sample culture has an initial population of 874 bacteria. Find the predicted population after 5 hours. Round, at the end only, to the nearest tenth. All right, so there's a couple of things in here that we want to draw your attention to. The first thing here that we're going to notice is that it says it's a continuous exponential growth model. So continuous, that should immediately say in your mind, oh, continuous, I remember. Whenever it says continuous, that's a special formula. For money, that was the PERT formula, but in this particular application, it's the generalized formula, A equals A naught e to the RT. This is very similar to the PERT formula. The only difference is that the A has been replaced with an F and the A naught has been replaced with a P. So, the second thing we want to pay attention to is that it says it's going to increase. This is very important. If it says increase, then R is going to be a positive number. If it says decrease, then R is going to be a negative number. So for example, in this problem, it increases at 13%. So that tells me that R equals 0.13. But if it had said decrease at 13%, then you would use R equals negative 0.13. So positive for increase and negative for a decrease. You have to pay attention to that when you see that in problems of this type. Okay, great. So let's go ahead and identify what the variables are, and then we'll plug into our equation. We have A naught, E, sorry, that's a mathematical constant, I don't have to write that, R and T. Okay, let's read the problem again and we'll fill in what we know. The number of bacteria in a certain population is predicted to increase, so that's going to be a positive coefficient R, according to a continuous exponential growth model at a relative rate of 13%, which we'll write as positive 0.13 per hour. So time is measured in hours for this problem. Suppose that a sample culture has an initial population, that's A naught, the amount when the time is 0. So A naught is 874. An initial population of 874 bacteria. Find the predicted population, so the amount in the future, after 5 hours. 5 hours. And then round to the nearest tenth, but only at the end. All right, let's plug in. So A equals A naught, which is 874, e to the 0.13 times time, which is 5. So A equals 874 e to the 0.65. All right, put this in your calculators. Do this part first, because that's what order of operations says we must do. All right, so here we go. E to the 0.65 is 1.915540829. Then multiply by 874, and we get 1674.18265, rounding to the nearest tenth, which means 1 decimal place. Then the amount would be 1674.2. And that tells us how many bacteria that we have.